work is going to be equal to negative P delta V because we're taking the frame of reference of the system. So I want you to use this equation. Anytime you have a changing volume and you want to find work, you've got to use negative P delta V. And as I'm defining here the pressure is not from the gas inside of the system. It's actually from the outside gas pushing back on the system. That's the pressure that the system has to overcome. You okay with that? Now, I didn't probably label it correctly because I said expansion here. Does that mean that compression is positive P delta V? That's not true. I mean, the work equals negative P delta V whether the gas is doing that or doing that. It just happens if it's doing that, then the delta V is going to be positive because it starts small and gets big. That's a positive delta V. So that means the work is going to be negative. If the gas expands, the work is negative. If a gas is compressed, work is done on the gas to compress it, and therefore the work would be positive. Because delta V is negative, you're going to have a negative of a negative. I hope that made sense. We'll do the math here with it.
Oh.
And yeah, Kenny?
Also, P is always constant, right?
Yeah, P is going to be a constant. It's the just the external pressure pushing back on.
So that one law has nothing to do with it.
The what has nothing to do with it?
That one law, the PV equals PV.
Right. Yeah, it doesn't. Take a look. Number one is a pretty Mickey Mouse example. We'll start with that, just so you can see the sign convention on these, and then we'll try number two. So we have a system releases 125 kilojoules of heat, while 104 kilojoules of work is done on it. So we've got heat and work. You remember the symbols for heat and work? 125 kilojoules of heat. What symbol do we get for that?
Q.
That's Q. Is it positive or negative?
Negative.
Right. It's negative because it's releasing heat. Good. Okay, we'll come back to that. While 104 kilojoules of work, what symbol do you want to use for that? That's W for work, is done on it. Is the work going to be positive or negative?
Positive.
Work is being done on the system, therefore it's positive. That's right. Yep. If the system is doing work on the surroundings, like expanding itself, pushing back on the surroundings, then the work is negative. Okay, so we have a formula. This is the first law.
This means that the volume is decreasing.
We can assume that, yes. Yep. Yep, it's being compressed. Okay, so we have Q, which is negative 125 kilojoules, because it was releasing heat. Plus, we decided the work was going to be positive because the work was being done on the system. That's it.
Push everything.
We just add a couple of numbers together. So what is our delta E? It would be that negative plus that positive, negative 21 kilojoules.
1,000 joules.
So the release of energy kind of dominated our change in internal energy. It lost more energy than work that was done on it, so overall there's a decrease in internal energy. Okay with that? Number two. Is it time to go? Ah, shoot. We'll start with this one
It's an
tomorrow.
ideal gas, so that means that it's
Oh, you have
pressure.
to change it.
If it's a constant
You actually
volume,
milliliters to liters.
pressure.
Yeah, you have to change the milliliters to liters to find delta V. What is delta V in this problem? It goes from 5 liters to 5 milliliters. Ooh.
0.0.
Changes by how much?
Negative.
10 to the second.
I'm going to say that the delta V is negative 5.0 liters. I want you to chew on that, and we'll talk about it tomorrow. Goes from that to that, I'm going to say the delta V is negative 5.0. It's a sig fig issue. It's what, Kate?
Let me get this masterpiece.
I hope so. Thank you, Sean.